Problem 2. As shown, there is a square piece of metal with a side length of 180 centimeters. So here is 180 centimeters. On each of the corners, a smaller square with a side length of 40 centimeters is removed. So each of these identical squares from the corners are removed. So we now kind of have this plus sign right here, that plus sign. What is the area of the largest possible square you can cut from the remaining part? So out of this remaining part, after these squares have been cut, what is the largest square we can get? Well, many of you just go ahead and say, well, that's easy. It's literally right here. This isn't even challenging at all. Right there, that's my square. Yes, that is a square. But the question is asking for the largest possible square. And, if this is the square, then you're gonna, there's these 4 whole rectangles whose area you haven't used. And these rectangles, keep in mind, they are identical. So if we try to expand our square into all of these sections, that would only mean it has to be tilted. So that would look something like this. That's not the perfect square, but this is about the best I can do. So this whole thing is a square. And this is our largest possible square. So this is our square, and we found it, right? But we still have to find the area. So we first you have this. Okay, so we first have, and I'm gonna use what? We first have this square right here, and this has a side length of 100, so that would be 10,000 centimeters squared. Plus, and we have these triangular parts, 4 times, and we have these triangular parts. So, and as you can see, this triangular part is 1/2 of these smaller, thinner rectangles. So first we can do 180 times 180. Then we can minus 10,000 from it. And then we divide that by 4. And we divide that by 2. So we know that each of these would be 2,000 centimeters squared. So 2,000, right? And 4 times 2,000 is 8,000. So our final answer is 18,000 centimeters squared.